this is Mr. Precella working some problems with this trig class, getting ready for the final exam. So we're up through number 13. Graph the function y equals -3 cosine x plus pi over 2. Now that's something that it wasn't that long ago we were doing, okay? That was on the third test, which I guess now it's like 2 weeks ago that y'all were studying for the third test, if I'm remembering correctly. Let's see, what's the amplitude going to be here? I'm going to find the amplitude. It would be 3, so it's going to be bouncing between 3 and -3. To figure out where the graph starts and stops, you take the angle, that's the stuff immediately after the trig function, the x plus pi over 2, and set it between 0 and 2 pi. And I guess we can subtract pi over 2 all the way through. So we have a negative pi over 2 less than x. Let's see, 2 pi minus 3 pi over 2, minus pi over 2, 360 degrees minus 90 degrees is 270 degrees. So that would be, or 4 pi over 2 minus 1 pi over 2 is 3 pi over 2, however you want to call it. Now this is a cosine curve. So let me think of the general shapes. Sine looks like this. This black curve here is y equals positive a sine x, and this is where a is positive. Be bouncing between a and negative a. Now if a were negative, then it gets reflected across the x-axis, doing something like this. This is where a is negative. And why am I going through all that detail on sine? Because that's not what we're graphing. We're graphing cosine. So what does the graph of cosine look like? Let me see. This is just what I'm thinking. Cosine starts up here, does something like that. So this is y equals a cosine x, where a is positive. If a were negative, it'd do something like that. This is where a is negative. So let's see, what are we going to have? It's going to look like one of these graphs, the black or the green, or the black or the red. You all caught up with me? The red, yeah. So it's going to start at negative pi over 2 on the x-axis. I'm going to use 2 little marks for pi over 2, so 0, pi over 2, pi, 3 pi over 2. And what number am I going to label on the y-axis? What numbers, I should say. 3 and -3? How am I choosing those? The amplitude. And it's going to look like the red one, except instead of starting here on the y-axis, it starts at negative pi over 2. So 1, just plotting the 5 key points, 2, 3, 4, 5. So here's what the graph looks like. Now realize this graph keeps going and going and going. So there's nothing that says that they've got to be showing from negative pi over 2 to 3 pi over 2. So let's see what it's showing. You look at all the options, the A, B, C, D. They're showing 0 to 2 pi. So what I would do is focus just right out here. Which part of the graph looks like it's doing this at the y-axis? Well, it's not A. See, I'm looking at right up there. It's not B. Oh, wow. It's not C. Is it D? Oh yeah, okay, it's D. You can see it continuing on and so forth. Okay? If I'm choosing D as the graph, I looked at just right here on the around the y-axis, what's the graph doing? Okay? Or if you want to say, okay, at 3 pi over 2, it should be down at negative 3. Which one at 3 pi over 2 is 3 pi over 2 is down at negative 3? No, not that one. Not that one. Not that one. And, well, it is that one. Okay? Any questions how I'm deciding on D there? Okay. Oh, wow. And in my traditional organized cell, I've lost the next page. Let me see. Let me shuffle through these. Number 14 is some of that multiple choice matching. Okay. 14, multiple choice matching. Well, let's see. Tangent and cotangent. You should have to draw all of these. I'm just going to think of tangent and cotangent. So I'm going to graph y equals, let's think about the graph of tangent x. That's a positive. Tangent, is that the one that has asymptotes at 0 and pi, or at negative pi over 2 and pi over 2?
Negative pi over 2.
Negative pi over 2 and pi over 2. And tangent, when you're looking from left to right, is it going up when you look from left to right or down? Up, Now, in the first quadrant, 0 to 90 degrees, all the trig functions are positive. So it's got to be above the x-axis there. So here is the graph of y equals tangent x, positive tangent x. That's not what we want. Because number 3 is y equals negative tangent x. The graph of that would go down like this. So I'm looking for number 3, negative tangent x. Which one it should be going down, right here, passing through the origin, and have asymptotes at negative pi over 2 and pi over 2. Well, the two that have something that look like this are A and C. The one that looks like what I've drawn here in pink is C. So number 3, the answer is C. And well, I guess by default, what do you think number 4 is going to be? Number 4A. Maybe I should do one of these secant or cosecant ones. Okay, we've probably done enough right now to figure out which one the answer is. The way you read these answers down here. See, there's 2 different A's, 2 different B's, C's, and D's. This answer A says 3 is B, 4 is D. It's not that one. Right here, this answer B has 3 is C and 4 is A. So we could already decide that's the answer. But maybe I should draw one of the cosecant or secant ones just to do an example. If I were going to graph y equals cosecant x, I would first graph what? What's the reciprocal of cosecant? Sine or cosine? Sine. So I'm going to graph y equals sine x, and I'll do it in blue. So 0, 2 pi, so right here's pi. It would look something like this. Y equals sine x. It'd be bouncing between 1 and negative 1. 1, 2, 3, 4, 5. There it is. Now, if we wanted y equals negative sine x, we would flip it like this. Oops. Wow, why did y'all let me? I missed this completely there. This should have gone like that. What did I do there? Okay, sorry. So, asymptotes. And draw the little U-shaped figures. So, the graph would be either B or C. Which one, if we look just from 0 to pi, which one of them looks like this here? From 0 to pi, I'm thinking it has to be B. Okay. The pink is y equals negative cosecant x. It's not D because it doesn't actually cross the y-axis like that, does it? So 1 is B. Which means 2 has to be, which one have we not used? D. And there were still some of you that had trouble figuring out how the heck you were supposed to read the answer. Problem 1 is graph B. Or function 2 is graph D. Function 3 is graph C. Function 4 is graph A. This, if you're going to circle an answer, and there were some of you that didn't write an answer in the blank, instead you circled an answer, and there were some people that circled these. Those aren't the answers. If you're going to circle an answer, it's going to be this one right here. Okay? If you're still having trouble figuring out what the heck or how the matching works, speak to me about it after class. Okay? Or right now. Any questions over that? It's supposed to be sort of a lax problem because, my gosh, you have your choice. Which function do you want to graph? If you do cosecant, once you've done that one, you know secant also. It's the other one with the u's. If you do tangent, you know cotangent. That should be enough for you to figure it out. You're not really supposed to graph all of them. I did it just for illustration purposes. Okay. Now, let's see, 15, 16, 17. Ooh, I borrowed someone's unit circle on. Let me give that back to you. I'll drop my phone. Let's see, we're going to be looking at inverse trig functions for 15, 16, 17. For the trig functions that have the O in them, you're looking from 0 to pi. That would be inverse cosine and inverse cotangent. You're doing 0 to pi. For the ones that don't have an O, you're looking from negative 90 degrees to positive 90 degrees. So let's remember, you're not going to be using these angles. You're going to use, let me see, I'm going to use this orange, which is sort of invisible. This would be negative 30 degrees, negative 45 degrees, negative 60 degrees, negative 90 degrees. If you can't see it, well, yeah, it's invisible. You're doing, for inverse sine, well, you know what, let me write it down here. Inverse sine and inverse tangent. The ones that don't have the O in their name, you're using these. Now for inverse secant or cosecant, the way we did it was just flip and use the reciprocal function. I don't know if that's going to pop up. But for all of them, you use the first quadrant. For inverse cosine and inverse cotangent, if the number's negative, you're using this quadrant. For inverse sine and inverse tangent, if the number's negative, you're using this quadrant. And the negative angle measurements. Negative 30, negative 45, negative 60, negative 90, or in radians, if that's what it's asking. On number 15, it's inverse cosine. Inverse cosine negative square root of 3 over 2. So you're going to be looking all out here, 0 to pi. Well, nowhere in the first quadrant is cosine negative. So it's going to be over here. Where's cosine negative square root of 3 over 2 at 5 pi over 6? Okay. Any questions there? You might be thinking about, you're not right. There's not a lot of work to show on this. You've got to know, look over here. Where's cosine negative square root of 3 over 2 at 5 pi over 6? Now number 16, there's a little bit of work. For inverse secant and inverse cosecant, we didn't actually define those. We just said, okay, write it in terms of the reciprocal. The reciprocal of cosecant would be sine. So we're going to go inverse sine and then flip. So that would be a negative square root of 3 over 2, flipping the negative 2 over square root of 3. Oh wait, I'm using I guess that invisible ink is showing there. Oh, okay, I'll make it like it's deliberate. Why am I using this orange ink? Well, because inverse sine, you're going to be down here. Don't use these angle measurements. Use the negative. So where's sine negative square root of 3 over 2? Down here in quadrant 4. Oh, wait. Oops. Let me see. How can I do this so it'll all show? Oh, I know. There's number 16. We're looking down here. Let's see. 5 pi over 3, which is not what I'm going to choose. What am I going to write? It's negative. I'm thinking it's, first of all, it wants it in degrees. So negative 60 degrees. Negative 60 degrees, sine is negative square root of 3 over 2. So negative 60. Okay. Any questions there? Then you're going to do the same thing with number 17 using the same interval. Okay? Let's see. Move it over. It says arc tangent negative square root of 3 over 3. Well, since it's inverse tangent, that's when we're using the negative 90 degrees to positive 90. It's not going to be up here in the first quadrant because all of those tangent values are positive. It's going to have to be down here. And can you do the calculation in your head? When would we get negative square root of 3 over 3? For which one of these? Either negative 30 or negative 60. If you go sine over cosine, say it again. Negative 30. At negative 30 degrees, if you went sine over cosine, you'd have negative 1/2 all over square root of 3 over 2. Multiply above and below by 2 to get negative 1 over square root of 3. And can y'all rationalize that in your sleep at this point? You would multiply above and below by square root of 3. So yes, all I'm doing here in blue is verifying that negative 30 degrees is right. Right here, 330 degrees or 11 pi over 6, or for what we're doing here, negative 30 degrees. Sine over cosine is negative square root of 3 over 3. Okay. Any questions there? And at that point, we're through using these negative angle measures here. Okay? So we're up to number 18 now. Solve this equation. Okay, well, this equation, it's already factored with a 0, so what are you going to say? You're going to say, well, the only way two things can multiply together and give you 0 is if one of those factors is 0. So set tangent x plus 1 equal to 0 and cosine x plus 1 to 0. So we're going to be looking at the unit circle. Let's see, move the 1 over, and we have tangent x equals negative 1. And what about moving over here, move the 1 over? Cosine x is negative 1. So let's see. Look at the unit circle. Where's tangent x equal negative 1? Don't use any of those negative angle measurements. So even though it's invisible ink, I'll go ahead and mark those out now. Was it Erica one day that didn't like all the marking out on something I had? Like marked out a unit circle and stuff on there. Oh, ooh, let me see. Will it all fit on there? Oh, am I going to have to zoom it out some? Well, that's good enough. Where's tangent equal to negative 1? Well, sure not here, but at 3 pi over 4 and also at 7 pi over 4. So 3 pi over 4 and 7 pi over 4. Where's cosine equal to negative 1? Cosine would be negative 1 at, oh, not there, but at pi. So let's see. We're writing these in numerical order. It's going to be A, isn't it? I mean, they're listing all three of the angles. They don't always do that, but sometimes they do, I think. Okay, this is some of the more recent stuff. Sort of rushing to get to those problems like 22. Should have enough time to get it all done, but let's see, number 19. Well, that one's not already factored, is it? So let's see, what can we do on this one? Factor out a sine x. Is that what Catherine said? Did y'all hear that? I factored a sine x out of each one of these. What's going to be in the parentheses? Sine x, what do I have to put in here so I can distribute? I need to be a 1, and then a minus 2 cosine x. I factored a sine x from each term. And now it's like number 18. It's factored on the left with a 0 on the right. So I'll set the sine x equal to 0. And I'll set the 1 minus 2 cosine x to 0. So let's see. Move the 1 over. To get a negative 1. And then divide both sides by negative 2. So cosine x is 1 over 2. So you're looking at the unit circle. Where does sine x equal 0? Where's cosine x 1 over 2? So where's sine x equal to 0? Well, that would be at 0 and pi. That's where sine is 0. Where's cosine equal to 1/2? Pi over 3, and where else? 5 pi over 3? So pi over 3 and 5 pi over 3. Any questions there? So we're going through these quickly because these are ones that are some of the newer material. Trying to get to 22 and 23. That's some of the stuff that was on your second test. Okay, number 20 is cosine x plus 5 pi over 3 plus cosine x minus 5 pi over 3 equals 1. Well, don't start by distributing the COS. That's not how you expand stuff like that. It's cosine, change sine, cosine, change sine. That pink stuff was this first thing expanded. Ooh wee. You have to write smaller to get it all on there on one line. Now the plus I'm about to write is the plus I just circled there, so you can sort of stay up with me. Now I'm about to do the next cosine in green. So it's going to be the same identity, except I'll be changing that middle sign. So this pink plus with a minus, it's going to be a plus. It's cosine, change, so plus, sine, equals 1. Some of this stuff is going to subtract out. Let's see. Is it the sine terms that subtract out? This and that. And let's go ahead and combine these. Cosine blah blah plus cosine blah blah would be, or I should have said 1 cosine blah plus 1 cosine blah. That's going to be 2 cosine x cosine 5 pi over 3 equals 1. Now, I'm carrying down the 2. In red, I'm going to look at the unit circle and replace cosine 5 pi over 3 with whatever it is. Now, do I have my unit circle here? Cosine 5 pi over 3. Cosine 5 pi over 3 is 1/2. So I'm putting a red 1/2 right here. And we still have that cosine x here. Realize multiplication, it doesn't matter the order. I reversed those. That's why I put the 1/2 here, just so it's right beside the 2. So you see those cancel out, leaving you cosine x equals 1. Where the heck does cosine x equal 1? Well, that's not hard to figure out. Cosine is 1 at 0. And also at 2 pi, but it only wants us to list the 0. That's what this notation right here means, with the bracket on the 0 and the parentheses on the 2 pi. It means don't list the 2 pi, just list 0. So x equals 0. And y'all caught up? Oops. 21, we're going to do the same thing. Only we're using a different identity on it. Let's see, what do we have? Sine, x plus 11 pi over 6. Okay. I'm going to expand this first stuff in pink. So I'm using pink to expand that sine x plus 11 pi over 6. It's sine, cosine, same, cosine, sine. The symbol I'm about to write is that symbol I just circled there in blue. It all looks black, I suppose. And now I'm going to do the sine x minus 11 pi over 6. Pardon me. And I'll do that in green. So sine, cosine, sine, cosine, sine equals 1. Now, what I've written there isn't really right, because this minus should apply to all of this green stuff. So if I put parentheses around that, I'm trying to hint that you need to distribute that minus. If we distribute this minus, that's going to be minus sine x cosine 11 pi over 6, and then a plus. So with that in mind, which of these terms are subtracting out? The sine cosine or the cosine sine? The sine cosine? So we have a positive cosine x sine 11 pi over 6 plus, let's see why it's a plus, distributing this negative. So we have 2 cosine x sine 11 pi over 6 equals 1. Now, rewriting, I'll write down the 2. I'm going to look at the unit circle and see what's sine 11 pi over 6. Let's see, where's my unit? 11 pi over 6 is right here in this fourth quadrant. Sine, is that what I'm looking for, or cosine? No. Sine 11 pi over 6 is negative 1/2. And then we have cosine x equals 1. Let's see, so we have a negative 1 cosine x equals positive 1. Multiply or divide both sides by negative 1. Is that what you would do to get the cosine x by itself? So we have cosine x equals negative 1. Are y'all caught up with me? So where is cosine equal to negative 1? Cosine is negative 1 at pi. Now, sometimes students start making up all these little rules. Oh, well, it's always the one that just has one answer. That's just how the numbers worked out. This thing regenerates over and over. I think if you look at either your third test or the third review sheet, you'll see somewhere it's not just always the one that only has one number there. That's just how it worked out on these two particular problems there. Okay? So don't make up some rule that isn't true. Okay. Any questions on that? So we're about to go back to some older stuff. Number 22 is where the calculator problems start. Okay. Anywhere there's any sort of number crunching, Jerry told me he did all of them without a calculator, and the numbers worked out really easily. And I was like, oh, well, anytime there's a possibility of the numbers working out messy, that's where I'm sort of assuming you have a calculator. So starting with 22, that's a calculator problem. And going to move it up, and we'll get started on that. So we're doing number 22 right now. We're told to find tangent s minus t. So that means, what's that? I'm just doing my thoughts here. If it says find tangent s minus t, that means I need to know tangent. What's the formula for expanding tangent s minus t? Is tangent s, same symbol, tangent t, all over 1, change the symbol, tangent s times tangent t. Notice we're not given either tangent s or tangent t, so we're going to have to figure that out. So the way we do that, I'm going to write all the s information that we're given in blue. We're told cosine s is negative 5 over 13, and also s is in quadrant 2. So in quadrant 2, that means x's are negative and y's are positive. Now what about the t stuff that we're given? We're told sine t, pardon me, 15 over 17, and t is in, quadrant 2 also. Okay. So once again, quadrant 2, x's are negative, y's are positive. Now I'm going to do the x, y, r stuff on this one. X, y, r. Let's keep in mind, we already know that because of this information right here, I know x is green negative, y is a green positive. And what's the definition of cosine in terms of x, y, and r? It would be x over r. So negative 5 over 13. Now we've got to find y by saying x squared plus y squared is r squared. So now trying to find y. So x squared, negative 5 times negative 5, that would be 25, plus y squared, I don't know why, equals r squared. 13 times 13 is 169. I'm very silent. Are y'all caught up with me? Any questions? I'm going sort of fast on this. And I'll subtract the 25 to get y squared equals 169 minus 25. Is that 144? So is y going to be positive 12 or negative 12? There's really two of those. Positive, because we're told right here that y is in quadrant 2. So that's, the s is in quadrant 2. So y has to be positive. So at least at this point, we can find tangent s. Tangent s would be y over x. Now let's do the same thing over here. When you were doing problems like this in your homework with my math lab, if you clicked view an example, instead of doing this, what I've done here to find those other angles, what they would have done would have used sine squared s plus cosine squared s equals 1 to find cosine, and then go sine over cosine. I think using the x, y, r definition is a better way of going about it. If you know one trig function and you've got to find another one, the way I've done it consistently all semester is x, y, r. Quadrant 2. Quadrant 2, x is negative, y is positive, sine is y over r, See why? Might want a calculator on these. I'll do the same thing I did over here. X squared plus y squared is r squared. So we have x squared plus 15 times 15. Oh gosh. Do I have a calculator? 225? Yeah, 225 equals r squared. What's 17 times 17? 289. So I would subtract the 225. 289 minus 225. Is that going to be a 64? So x is going to be an 8, either positive 8 or negative 8. Which one? Negative, And all the problems on here, this is probably one of the these are some of the most involved ones. That's why I was rushing on them to get down here. Okay, so we need tangent S minus tangent T. I think I better get another sheet of paper. I think I'm running out of room here. So tangent S minus tangent T. The tangent S, that's y over x y over x, so 12 over 5, minus tangent t, the t stuff is in red, that's y over x. Is that going to be a negative 15 over 8? See how I'm doing this?
Tangent S, negative 12 over 5.
Oh. Tangent S is negative. There, thanks. Positive over negative. Thanks. Negative. 12 over negative 5, so negative 12 over 5. This minus here is the one from the formula. Tangent T, y over x, negative 15 over 8, all over 1 plus tangent S times tangent T, that's the negative 12 over 5 times a negative 15 over 8. I'm going to write this just to make it look a little bit cleaner. We have negative 12 over 5, and that's going to be a plus 15 over 8. And on the bottom we have 1. This is going to stay a plus. We have positive, then negative times negative. Let's go ahead and multiply those. The bottom would be 40. What's 12 times 15? 180? Oh, I should have known that. See how I got to that point there? And I'm going to simplify this by multiplying above and below by, if I multiply above and below by 40, would that get rid of all the fractions within the fraction? I'm thinking it would. If I multiplied by 40, it means I'm going to have to distribute. So let's see what we have here. Okay. On this first one, negative 12 over 5 times 40. 5 goes into 8 to 40 8 times. 8 times negative 12. Let's see where I got the negative 96. I went 5 goes into 40 8 times. 8 times negative 12, negative 96. Then a plus. Now multiply the 15 over 8 by 40. 8 goes into 45 times 5 times 15 is 75. You might just want to punch this in your calculator. Okay. On the bottom we have a 40 times 1 is 40 plus, here the 40s are canceling. I'm hearing calculator keys. Maybe I'm just imagining. So probably I was just going to punch some of that messy stuff in the calculator to get it to reduce. So on the bottom I have a 220, and what do I have on the top? Is that going to be a negative 21? A negative 96 plus 45? Negative 21 over 20? Any questions there? It's messy. That one has a lot of messy manipulation. Let's see if I can get it all to fit on the screen. There. Okay. It's right there. Okay. Yeah, these are sort of some messy manipulation problems. Some analytic trigonometry there. Any questions? Let's hope the next one isn't quite this messy. Alright? Okay, number 23. Okay, number 23. Same type of problem, except instead of saying find tangent, it says find sine s plus t. So I'm going to set it up the same way. I'll write down everything about about angle s in blue. So cosine s is negative 1 over 6. We're in quadrant 3. And so that means both of them are going to be negative, the x and y. Quadrant 3, x and y are both negative. And let's see. Cosine t is negative 3 over 5. And that one's also in quadrant 3. So it's going to be more of that negative, negative. Both x and y should be negative there. X equals y equals r equals. It looks like we're going to wind up with a square root in our answer. It just can't be rigged to work out with really easy numbers, can it? X and y are both negative. Cosine is x over r. So I'll find y by saying x squared plus y squared is r squared. So x squared, negative 1 times negative 1, that's just going to be a positive 1. Plus y squared, r squared, 6 times 6, 36. So subtract the 1 to get y squared is 35. And now, which square root are we going to take? The negative, because we're in quadrant 3. Now I do the same thing with the t's. Cosine is x over r. Remember that in this one, x and y are both negative. So negative 3 over r is 5. R is always positive, isn't it? Then do the x squared plus y squared is r squared. Oh, this one's rigged to work out a little nicer. Subtract the 9 to get 16. y would be a negative 4. Now at this point, once you know those, you're ready to find any of the 6 trig functions. I could have said find tangent s plus t or something, but here it says find cosine s plus t. So that would be cosine. Oh, you're right. Oh, sorry. It says to find sine s plus t. Okay, sine s plus t. Thanks for correcting me. Sine, cosine, same symbol, cosine, sine. Now all of the S stuff I've done in blue. All of the T stuff I've done in pink. Just carrying this sign, this symbol here. Sine, cosine, cosine, sine, same symbol in the middle. Right? Same as the one in the middle over here. So let's see, sine S. That is y over r, so negative square root of 35 over 6. Cosine t, we were told that, negative 3 over 5. Cosine s, that's what we were told, negative 1 over 6. Sine t, sine is y over r, so negative 4 over 5. Negative times negative, that's going to be a positive 3 square root of 35 over 5 times 6, 30. And this is going to stay a plus. Negative times negative is positive. So plus 4 over 30. Okay. Well, it looks like they have it written with just one big fraction. So we're going to write it with just one fraction. 3 square root of 35 plus 4 all over 30. Which one is it? They all sort of blur together, don't they? Is it C? Okay. A lot of analysis going on there. Any questions on that? Anything I need to go back over? Those 22 and 23 are the ones I thought were the most involved. Then we have some problems involving double angle identities. Let me write those double angle identities down. Okay, so here are double angle identities. And they might pop up. Sine 2a, 2 sine a cosine a. And there's only one double angle identity for sine. It's the cosine one that can cause a little bit of problems, because there are 3 double angle identities for cosine. The first one is the one you get when you replace. If you go cosine, cosine, sine, sine, instead of using A, B, A, B, if you just go A, cosine A, change sine A, sine A. There's the primary double angle identity. Cosine squared A minus sine squared A. That's the primary one for double angle identity for cosine. To get the other two, you replace sine squared A with 1 minus, first replace cosine squared A with 1 minus sine squared A. So you get 1 minus 2 sine squared A. Or if you replace sine squared A with 1 minus cosine squared A, you get this, 2 cosine squared A minus 1. I told y'all at the beginning of the semester, this course has a lot of memorizing. This is different from algebra. And since I said I'm going to state the double angle identities, I might as well state the one for tangent, though I'm not sure that we're going to be using it. It's 2 tangent A over 1 minus tangent squared A. But on 24, 25, 26, I just glanced and I was seeing a 2 theta throughout in these problems. That's why I thought, oh, I better state these double angle identities. So on problem number 24. Ooh, I stated them, can't see. Okay, so on problem number 24, what are we told? Well, we're told that sine theta is 21 over 29. We're told cosine theta is positive. Okay. Find cosine 2 theta. Find cosine 2 theta. Well, to find this cosine 2 theta, we're told sine theta. So we're going to use one of these 3 double angle identities for cosine. And the one that would be the smart one to use would be the one that doesn't have a cosine theta in it. Like, we weren't told cosine theta. All we were told was that it was positive. If you want to do x, y, r and find cosine theta, then you could use this identity or this one. But if you go straight to this identity, 1 minus 2 sine squared theta, then all you have to do is just substitute in place of the sine theta, put 21 over 29, and let's see, we're given fractions on here. I know that my calculator doesn't really show well through this projector. It shows better on the videos. Let me just see. If I want to just punch this in, if you have a calculator like this, you should be able to punch it in exactly as it's written. Let me see. Okay, let me see. Maybe that's showing. One day it worked really good, just right here for my business math class. There's still that glare. And let's see, if I start punching in, is it showing, or you're all getting cataract because of that glare? 1 minus 2 parentheses 21 over 29. Oh. That glare is giving y'all cataract and you can't. Oh, is that better? Close parentheses, square. Can any of y'all see what I've typed in there? Now, when I hit enter, it's giving me a decimal number, but on this calculator, to convert that to a fraction, I go math. That very first thing there, I'll just say enter. Negative 41 over 841. So, and there's another problem I did earlier. And I was saying I was hearing y'all punching in your calculator, some of you. Yeah, that would have been easier. Negative 41 over 841. Let me find the problem. This is that paper shuffling that I love so much. Right here. So they're not all as long as number 22 and 23, are they? Okay? But you had to know which, you had to make a smart choice on which identity you were going to use, which double angle identity. Okay? Since you were given sine, use 1 minus 2 sine squared theta. It can't all be that easy. Number 25. Let's see. Okay, we're told cosine is 12 over 13. Cosine theta is 12 over 13. Sine theta is negative. Find sine 2 theta. Well, there's only one double angle identity for sine, and that's 2 sine theta cosine theta. And it's not going to be as easy or as fast as number 24, but it's not going to be as long as 22 and 23. So, find 2 sine theta cosine theta. Well, we know cosine theta is 12 over 13. So what am I about to do to find sine theta? X, Y, R. Okay, good. So cosine theta is 12 over 13. They didn't tell us a quadrant, did they? Instead, they said sine theta is negative. So X, Y, R. So cosine is X over R. So R is 13. X is 12. Let's use this statement right now. Sine theta is negative. That should tell you whether y is going to be positive or negative. What would we use? What is that saying? Y's got to be negative. Sine theta is y over r. R is positive 13. So the only way sine theta can be negative is if y is negative. Now I'll do x squared plus y squared is r squared. So 12 squared plus y squared is 13 squared. So subtract the y squared. 169 minus 144 is 25. 8th grade math teacher, Mrs. McGowan, made us memorize these little numbers that would satisfy the Pythagorean theorem without any sort of square roots. A squared plus b squared, c squared. One of the little ordered triples that we had to memorize was 5, 12, 13. And the goal was so that when we looked at this, you knew 12, 13, the missing number had to be a 5. In this case, it has to be a negative 5. Okay. At the time, we didn't know why she was making us memorize those. We just memorized them. I remember her standing up there. We had a little test over these. She'd say 2 numbers, and she was going so fast. And you had to write down the 3rd number. Okay. But anyway, I forgot what I was doing. Oh. Right here, there's 2 sine theta cosine theta. I'm ready to finish it up. 2 sine theta is y over r. So negative 5 over 13. And cosine theta, we were told, cosine theta is 12 over 13. So multiplying all of those together, the bottom we have 169, and what do we have on the top? Negative 10 times 12, is that a negative 120? Y'all follow that? You use the x, y, r to find sine theta, and then you're going 2 sine theta cosine theta. try to do this one more, and then we'll pick up with the word problems on Wednesday. I still think we can get it all done. We're reviewing for our final exam, and few students have already taken the final exam for one reason or another. Let's take it early. Okay. Oh wait, no, we're not doing that one. Which one are we doing? Number 26. Well, on 26 we were told cosine 2 theta is negative 7 over 9. Then we're given some information that theta is between 90 and 180 degrees. Theta is between pi over 2 and pi. So that means we're in which quadrant? Second quadrant. So in second quadrant, x cosine is negative, sine's positive. It's number 26. Okay, we're told cosine 2 theta. We're told find sine theta. So sine theta is what we're looking for. Let me bring these down. See that tangent 2 theta didn't pop up there, did it? Okay, but once again we're confronted with this double angle. What I'm about to do is replace this with one of these three. Which one of these would be the smart one to replace that with if we're trying to find sine theta? 1 minus 2 sine squared theta. If it had said find cosine theta, you do this one. You sure wouldn't use this one. Okay? So I'm replacing this cosine 2 theta with 1 minus 2 sine squared theta. It's negative 7 over 9. Now I've got to go through and solve this thing for sine theta. Back in the day, I used to teach a lot of remedial classes. So the remedial teacher in me wants to multiply both sides by 9. If you don't want to get rid of the fraction, okay. I would have a 9 minus 18 sine squared theta equals negative 7. Now how would I go about solving this for sine theta? I would have to subtract 9. So I'd have what, a negative 18 sine squared theta equals negative 16. Divide both sides by negative 18. So quiet, are y'all following what I'm doing? Keep saying I'm going fast, I know it, but yeah, I don't slow down. Okay? So we have sine squared theta equals, let's see, 16 over 18. Would y'all reduce that to 8 over 9? Cool. We have sine squared equals 8/9. So we're about to take a square root. Oh, and I shouldn't have used them. I messed up with my color coding. Let's pretend I wrote all of this stuff right here. Well, even if I say purple, I've already used purple. But anyway, it's going to be this information right here that lets me figure out whether I'm going to take a positive square root or a negative square root. If we're in quadrant 2, if theta's in quadrant 2, in quadrant 2, X is negative, Y is positive, so which square root am I taking? In quadrant 2, sine is positive, so positive square root of 8 over 9. Well, the square root of 9 is 3. How do y'all simplify the square root of 8? 2 square root of 2. So we're getting a positive 2 square root of 2 over 3. Okay. So this one right here, C. So we should have time to finish these up tomorrow.